better understand aerodynamic forces, early pilots and engineers pushed aircraft's tolerances to the limit. But by pushing the limits, some pilots experienced a very frightening aerodynamic phenomenon called a flat spin. In an effort to better understand this phenomenon, NASA's predecessor, NACA, developed a unique wind tunnel called the 20-foot vertical spin tunnel. This tunnel was designed to not only study the unique flight conditions of an aircraft in spin, but also teach pilots recovery techniques to avoid a fatal crash. The research performed at this tunnel would have a direct impact on virtually every American aircraft from World War II through today. Early in 1941, the National Advisory Committee for Aeronautics, or NACA, completed its new 20-foot vertical spin tunnel. This tunnel tested a very different type of flight situation than the tunnels researchers were accustomed to using. The traditional way to test aircraft in a wind tunnel is by mounting an aircraft in the wind stream to evaluate the aircraft's flight characteristics. This type of testing is very effective when testing an aircraft in normal flight situations. But data from a traditional wind tunnel could not adequately account for unusual flight conditions, like a flat spin. As a plane enters a flat spin, air is not moving over the control surfaces as it should, which renders the plane's controls virtually useless. To help find ways for aircraft to recover from these dangerous spins, researchers test small-scale models in the spin tunnel. The idea behind the spin tunnel is simple. A large fan pulls a column of air up through the middle of the tunnel. Then a researcher launches an airplane model directly into the airflow by hand. As the model spins downward, the operator increases wind speeds until the model's fall is just balanced by the uprushing air. Then the control surfaces of the model are systematically activated electromagnetically to find out which ones allow the model to recover from the spin. The same basic technique that was used in 1941 is still being used today, but researchers now use computers to track unique markers on the bottom of the plane to measure the aircraft's spin characteristics. With these measurements, researchers can determine design modifications and pilot training procedures which can help pull a plane out of a spin, saving the plane and the pilot from a catastrophic accident. This simple system has worked especially well over the years. During World War II, every fighter, light bomber, attack plane, and trainer, over 300 designs in all, were tested in the spin tunnel. Subsequently, over half of these aircraft were modified in some way to ensure that their controls would be able to pull them out of a spin. Today, the spin tunnel is still testing many different types of designs, from small general aviation planes to the Mars sample return capsules. Since it opened for business in 1941, nearly every American military fighter has been tested in this tunnel. However, with 10% of all military air accidents still occurring due to the flat spin, the NASA Langley 20-foot vertical spin tunnel will undoubtedly continue to save lives for many years to come.
Did you know that Lieutenant Francis Evans became one of the first aviators to develop an effective spin recovery technique? In 1917, while attempting to get his pontoon plane into a loop, Lieutenant Evans inadvertently went into a spin. As he maneuvered out of the spin, he realized that he had unwittingly discovered an effective spin recovery maneuver. He was awarded the Distinguished Flying Cross nearly 20 years later for his life-saving discovery.